factorising non-monic quadratics by grouping. So previously we've dealt with monic quadratics, that is where the coefficient of x squared is 1, and so we just have x at the start of both our brackets. This is non-monic quadratics, where the coefficient of x squared is a number that's not 1 or 0. This will go through why it works. I won't revise the grouping method separately, so if you are struggling with that later, you'd have to check out another video, but I will do both of these by grouping. You should be all right. Non-monic quadratics are in the form ax squared plus bx plus c, where a, b and c are numbers and a is not 1 or 0. And to work out why our method works, it's an interesting idea to follow what happens with an expansion algebraically. We will do a method like the previous one where we used factors of one number to work out what we're splitting bx into. Let's expand this. Mx times px would give me mp x squared. So there's a number in front of the x squared, which I get by doing m times p, and that is our a. Mx times q plus mqx, n times px plus npx, n times q plus nq. These are like terms because remember each of these are just numbers. So I would get mpx squared plus, I'd add these together to get the coefficient of x, mq plus npx plus nq. Quite obviously, this is our A term, this is our B, and this is our C. So our B is made up of m times q plus n times p. The numbers have been multiplied together in the other order. I had np here, I've got nq. I had mp, I've got nq. But if I multiplied together mp, that is A, and C, that would be mp times nq, and that would be exactly the same as if we'd done mq times np. The same thing. So multiplying these two numbers together would get the same answer as multiplying these two numbers together. And so if I find AC, these two multiplied together, a pair of their factors will add to give this sum. These will be factors of these multiplied together, as we can see here. Oh dear, that's the bell. I will have to explain that in a separate video. Sorry.